right, welcome back. So, quizzes are getting graded, but we are actually kind of jumping backward a little bit. Okay, let me play this real quick. All right, so let's talk about where we're headed. So we've got 3 sections before the next quiz. All right, 3 sections before the next quiz. The next set of sections deals with what are called sequences. We're going to talk about 3 types of sequences. We're going to talk about what are called arithmetic sequences, which is what we'll do today. We're going to talk about geometric sequences, which is what we will do Thursday. And then we will talk about recursive sequences, which is what we will do on Friday. Okay, 3 different types of sequences. Well, really like 2, and then the third thing is just another way to write sequences. Now, it looks like we are going backward into chapter 4. I don't love where the book puts the arithmetic sequence section, because the rest of chapter 6 is all about sequences. Okay? Chapter 4 was all about linear functions. Now, you're going to see here throughout the day that arithmetic sequences are very similar to linear functions. So that's why they're in that chapter. But what we decided to do is take arithmetic sequences, remove them from chapter 4, and lump them together with all of the other sequences stuff. Okay? Because I would have taught you what a sequence was way back in like November, and now we would have had to go back to it and say, okay, remember sequences? Now we do this with them. So we just decided to lump them all together and do 3 sections about sequences. That means we will learn our lessons, and they're all one-day lessons, and I think you're going to find they're kind of easier than the stuff that we've been doing before. 3 one-day lessons, Wednesday, Thursday, Friday, and then we will review Monday, and then we will actually have a quiz next Tuesday over those 3 sections. But again, I think you're going to find that it's probably a little bit easier than this material that was on the last quiz. Now, as I come around with the guided notes, I want you to think about this. Find the next 3 numbers in that sequence. You don't have to write it down. I'm just asking you to think through. What would the next 3 numbers in that sequence would be? I want everybody to think about it. Okay, you don't have to write them down. Just think, what would the next 3 numbers be in this sequence? Gio?
8, 11, 14.
8, 11, and what? 14, you said?
Oh.
You're right.
Oh, yeah, 14.
8, 11, and 14? Yeah, that's right. Good. Now, what went on in your brain to do that?
Well, I saw at -4 went to -1, and then -1 to 2, and then 2 to 5, so it must be adding by 3.
Good.
And then I added 3 to 5, and then added.
You just kept the train rolling, right?
Added 3 to 11.
Just kept it going. He saw the pattern, recognized that it was a +3 pattern, and then kept it going. Good. I see +3s all around, so I just keep it going. Oops, gotta get a pencil. So 8, 11, and 14. Good. Okay. Guys, eyes up here, please. Take a look at this now. What if I wanted to find the 12th term in this sequence? When I say the word term, that's like a number of the sequence. Well, take a look at this. You know, could I do that same thing as the last slide? Sure, it's going to take me a little bit, but let's find the 12th term in this sequence. I'm going to write underneath it the term number. Term number 1, term number 2, term number 3. Here's the 4th, 5th, 6th, 7th, 8th, 9th, 10th, running out of room, 11th, 12th. So I'm going to make my list, I'm going to make myself a little table here with my term number on the bottom, and then I'm going to write this out on the top. Okay, so what's the pattern? Which is essentially all algebra is, right? Finding patterns within numbers and then using it to do things with it. +4 pattern. I see a +4 pattern. So I keep adding 4. So what's my next term? 5, then, 10, and that's the 12th term in that sequence. Okay, I mean, going up to 12 terms, that's not so bad. Yeah, question?
Can you just multiply?
We'll see here. I'll show you. I see. He asked, "Can I just multiply?" What he's trying to do is thinking, "How do I go from what I know to the end point without having to deal with all that junk in the middle?" Right?
Well, you know that you're going +4 every time, and you have 8 more terms left, and you ended on 1. So 8 times 4 is 32, plus 1 is 33. You can figure that out.
Ooh, plus. Oh, I see what you're doing. I like that. Yeah, what he's trying to do is create an equation to get us to our landing spot. Right? That's great. That's great. Could I list them out for 12 terms? Of course. What if I asked you that? Right? Right? 1, 2, 3, 4. Just keep adding. Just make sure you keep track, right? Now, I will tell you this. At the end of today's lesson, we're going to come back and do that problem, and it's going to take you like 20 seconds. Okay? So, now, I'm going to try to find the 412th term in the end. When we come back to that problem, we're going to find the 412th term. Now, I'd like you to do this. I'd like everybody to guess. I want you to write down in the top corner of your paper right now what you think the 412th term is.
Can you give us like a hint?
No, it's a big number.
Oh yeah, I guess so.
It's bigger than 33. I want you to guess at it. There's no shame in guessing. Come on, just guess at it. You have 5 seconds to write down your guess. 5.
Yo.
4. It's a guess. 3.
Well, that's the closest person.
I wrote down 1, 2, 3, 4, 5.
What's the closest
You
person?
get a high five.
You know what?
All right. Okay. So let's take a look at arithmetic sequences. These are examples of what are called arithmetic sequences. Arithmetic sequences. And that's how we pronounce that. Arithmetic sequences. Some people might try to call them arithmetic sequences. Okay, yeah, that's that same word. It's just pronounced a little different. Arithmetic sequences. Arithmetic sequences. Now, let's first off start talking about what a sequence is. Okay, and you've got some blanks to fill in here. A sequence is an ordered list of numbers. A sequence is just an ordered list of numbers. That list can be any type of pattern. And the pattern could be that there is no pattern. Again, you have some blanks to fill in. Please fill in your blanks. A sequence is an ordered list of numbers. And again, that it could be patterned. It could not be patterned. It just kind of depends. A sequence is an ordered list of numbers. Each number in a sequence is called a term. Each number in a sequence is called a term. Each term has a specific position in the sequence. Okay? Each term has a specific position in the sequence. Like, you know when I set up that table and I said, okay, I'm going to look at my first term, second term, third term? That term number is called n in our case. Like the first position, n is 1. The fifth position, n is 5. The third position, n is 3. The nth position is called a sub n there, right? The a sub n is the nth position. And that's how we read that, a sub n. Sub standing for subscript. Okay? A sub n is a subscript n. That's a nth position. Okay? Now, go ahead and write down these next 3 sequences for yourselves. And I want you to make some notes on some similarities and then some differences that you see. Okay, the following are examples of arithmetic sequences. First example, 4, 7, 10, 13, 16, 19. Second, 1.2, 2, 2.8, 3.6, 4.4, 5.2. Third example, 27, 21, 15, 9, 3, negative 3. Okay, some similarities and some differences that we see. Well, first similarity is that they all have that dot, dot, dot on the end of it. A sequence is usually never stopping. What does that dot, dot, dot imply? That pattern will continue forever. Is there a dot, dot, dot on the left side? No, that means that 4 is the starting number for this, and it's very important to pick up the starting number for these. 4 is my starting value. 1.2 is my starting value. 27 is my starting value. Now, 1 and 2 are similar in that I am increasing, right? I am increasing in sequences 1 and 2, but I am decreasing in sequence 3. I am going down in sequence 3. Okay, so that means that an arithmetic sequence can either increase or decrease. That does not matter. An arithmetic sequence could increase or it could decrease. Okay? Now, the key piece to the arithmetic sequence is something that we haven't even talked about yet. What makes an arithmetic sequence is something that we haven't even looked at yet. Do you see? I guess there's one similarity that all of them have. Can anybody tell me what it is?
Numbers.
They all have numbers.
They have
Brianna,
They all have some type of period.
what do you mean by that?
Like, not a decimal fraction.
Nathan?
They all start positive.
They all start positive. Okay, those are all similarities. Yes, not what I'm looking for yet. What else do we see there? You guys can find it.
They don't have the starting term.
They all have a starting term. That's true. Let me show you something that's not an arithmetic sequence, and maybe you'll get what you'll smell what I'm cooking here. Yeah, thank you. That is not arithmetic.
Wait, what?
Henry?
They increase the same amount each time.
Good. The red one that I put there is not arithmetic. Okay? That is what we will discuss tomorrow. Okay? This is what we're looking at today. So what do we notice here? Well, my first is up 3, up 3, up 3, up 3, up 3, and that pattern will continue. My second is up 0.8, up 0.8, up 0.8, and that pattern will continue. My third is down 6, down 6, down 6, down 6, and that pattern will continue as well. That's what makes an arithmetic sequence an arithmetic sequence.
So it has to be addition or subtraction.
Has to be. So what type of function would that be? Linear. And that's why this was grouped into the linear chapter. Okay? Because this is essentially a linear function. And there's actually examples within the homework that say graph. We're not going to graph. Okay? We're not going to graph because that's more of like a linear function. You would never really graph a sequence. You just got to know that an arithmetic sequence acts like a linear function. It's all going to increase at the same rate. So here's our definition of an arithmetic sequence. In an arithmetic sequence, the difference between each pair of consecutive terms is always the same. You have to have the same difference every single term. You have to go up by the same amount every single term. So plus 5, plus 5, plus 5. That's the same. That is what makes an arithmetic sequence an arithmetic sequence. Okay. Now, each term is found by adding that common difference to the previous term. So that amount that we go up, that is my common difference. Okay, we're going to call it D. There's my common difference. That common difference could be positive or it could be negative. Okay, and it's continually adding or subtracting, right? It's adding a negative to the previous term. That's an arithmetic sequence. So, first example here, right? The first 5 terms of the arithmetic sequence. I'm going to give you a starting term and then the common difference. That is very important information. Okay, starting term and the common difference is always really important. So I'm just going to start here with negative 11. And my common difference is 3. So what's my next term? Negative 8. Please don't say negative 14. Even though I'm using the word difference, do not subtract. A common difference is really telling me how much it's going up or down by. Positive means it's going to go up. Negative, it's going to mean it's going to go down. So this is going to go up in value to negative 8 and to negative 5. How many did we need to do? 5 terms? 1, 2, 3, 4, 5. Keep adding 3 each time. Negative 11 to negative 8, negative 8 to negative 5, negative 5 to negative 2, negative 2 to positive 1. Yes, sir.
it says 5 terms. Do you not have to put the 3 dots?
I guess you could think of it this way. For this specific problem, I only need these 5 terms, but if I'm talking about the full sequence, yeah, I would write dot, dot, dot.
Okay.
I would not take off if you didn't put it on there on this, but I would not take off if you did either.
All right.
Let's take a look at number 2. So my first term is 12.8, and my common difference is negative 2.4. So what is this? What is the negative on my common difference telling me about my sequence? It's going to go down, right? It's going to go down in value. So my first term is 12.8. My next term, okay. Let's see what we got here. 12.8 minus 2.4. 10.4. I'm going to keep going. Minus 2.4. 8. Minus 2.4. 5.6. Minus 2.4. 3.2. Those are my first 5 terms of that sequence. And again, that pattern would continue. You don't need that dot, 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 because I'm only asking for the first 5 terms. But remember that if I'm talking about the general sequence, that pattern would continue. Okay, so we know how to build a sequence now. Based on the necessary information, now we know how to build the sequence. So what if we were asking for that information to come out of it and determine whether the sequence appears to be arithmetic? If so, find the common difference in the next 3 terms. So my first example here, 9, 13, 17, 21. Is that arithmetic?
Yes.
Yes. It is arithmetic. And if it is arithmetic, it's telling us to find the common difference, and then the next 3 terms. What is the common difference here? Oh, what was your question then? Sorry.
Well, I think it's plus 4, right?
Right, plus 4.
But how do we know if it's arithmetic or not?
Let me show you by number 2.
Uh-huh.
Basically, it's got to always add or subtract.
Uh-huh.
Okay. So our common difference is 4, and so that means I've got 25, 29, and 33, right? Number 2. Is number 2 arithmetic? No. Because look here. I go minus 2, minus 3, minus 4. Is that all the same number? No. See, it's not always adding or subtracting by the same number, where this one was. This was a plus 4, plus 4, plus 4, right? This is minus 2, minus 3, minus 4. Something different. I don't know what it is, but it's something different. It is not arithmetic. Okay? So I don't have to find a common difference or anything. Okay, let's take a look at some fractions. Now, the nice thing about these fractions is that they all have the same denominator. And when they all have the same denominator, you can really just look at the numerators and see the pattern. When they all have the same bottoms, you can just look and see the tops to see the pattern. All right, so what are the tops? Negative 3, negative 1, positive 1, positive 3, plus 2, right, on the top. So we can say that this is arithmetic, and that my common difference, now I say it's plus 2 on the tops, right? What are these out of? 4, right? Right. I was adding 2 to the tops. And if these are all out of 4, I also have to put these out of 4. Now, what do I have to do to that common difference? Simplify it. It's got to be 1/2. So D is actually 1/2 here. Yeah, Gio?
Why does it go like 1/4 to 1/4? Like that's not adding anything.
Negative 1/4. You missed the negative sign. Negative 1/4 to positive 1/4. Now, the next 3 terms, I'm going to jump back to my 2/4 to find the next 3 terms. Because the top is going to be 5/4, add 2 to the top, 7/4, add 2 to the top, 9/4.
Do you have to simplify this?
I mean, you would, but don't give me any mixed numbers, only improper fractions. Taking a look at number 4 there. If I had a common difference here, I knew it would be out of 3, right? Because I have all the denominators of 3. So what's the pattern in the numerators? Is it arithmetic? No. Be careful with this one. It's very tempting to say that it is arithmetic, but it is not. I go down 1/3 and then go down 2/3 and then go down 1/3. It's very, very close, but it is not arithmetic. That middle in there, I go from positive 1/3 down to negative 1/3. So I'm actually going down 2/3. If there was a 0 in between the 1/3 and the negative 1/3, then it would be arithmetic, but this is not arithmetic. I don't know what it is yet, but we know it's not arithmetic. Questions on that so far? All right, taking a look at the back here. Now, this is not on your papers yet, but I'm going to do what Nathan was trying to do, but make an equation. The whole back is about making the equation. So let's see if we can kind of rationalize through what the equation would be. Everybody take a look up at the screens real quick. Look at this example. 4, 7, 10, 13, 16. What's my common difference, everybody? 3. Where did I start with this sequence? 4, right? So I started with 4. That's the first term, what we would call a sub 1, right? That's our first term, a sub 1. My next term, what did I do to 4 to get to my next term? Added 3. Now, if I want to say my next term, which is my third term, obviously it's 10, right? I don't want to think about going back to 7. I want to think about going back to my very first term. Go back to your very first term. How do we go from 4 to 10? What did I add?
6.
I added 6, which is basically like 2 3s, right? I added 2 sets of my common difference for my third term. I added 2 sets of my common difference, 2 3s, to get 10. How many sets of 3s do I add on to 4 to get 13? 3 sets of 3, which is 9, right? 4 plus 3 sets of 3. And then I could continue that pattern. That's a dot, dot, dot. I could do 5 sets of 3 to get to that pattern. 4 sets of 3, 12, adding on to the 14. So what's my rule? Well, think about this. If n is my position, how many sets of 3 did I add on in my fourth position? 3. How many sets of 3 did I add on for my third position? 2. How many sets of 3 did I add on my second position? How many sets of 3 did I add on my first position? 0. So what's the relationship between my position and how many sets of common difference?
Is that why Nate said add 1?
How many sets of common difference do I add on? 1 less. 1 less than the position. So that's really my formula here, okay? Which you see on your papers there. Go ahead and start, circle it, do whatever you need to do. There's your formula. You start with your first term, and then you add on n minus 1 sets of difference. You take your first term, and then you add on n minus 1 sets of difference. So what is each piece then? What is a sub 1? My first term. It was 4 in the one above. What is n? The place that you're looking for. So I wanted the 70th term, n would be 70. So you're going to add on n minus 1, 70 minus 1 sets of difference. And then you have to have your common difference d. So let's practice that a little bit. Write the equation and then find the indicated term. Write the equation and find the indicated term. So, for the equation alone, a sub n is equal to a sub 1 plus n minus 1 times d. And I forgot to say this. For the quiz next Tuesday, you have to memorize 2 formulas. This is one of them. The arithmetic sequence formula. First term plus n minus 1 times d. First term times n minus 1 times d. That's the arithmetic sequence formula. I would suggest every time you do a problem like this, you write it out, so then you don't have to memorize it. You don't have to work as hard to memorize it. So what is a sub 1 in this case? 4. Yeah, just like my other sequence, 4. It's my first term. What is my d? What is my d in the sequence?
4.
4. D is common difference. Plus 4, plus 4, plus 4. So D is 4 as well. Now, I'm going to build my equation using that alone. I'm kind of ignoring this 16th term yet. So I have 4 plus n minus 1 times 4. That's my equation for this arithmetic sequence. 4 plus n minus 1 times 4. Where n is the term number that you're looking for. So with this, I could find the millionth term in this sequence. I could find the 700th term in this sequence. Or if I could really want to, I could just find the 16th term in this sequence. So a sub 16, this is how we would write it. So that's my equation, right? That's half my answer. A sub 16, which is the 16th term, is 4 plus 16 minus 1 times 4. So 4 plus 16 minus 1, oh come on, 16 minus 1 times 4. 64. So a sub 16 is 64. Yeah.
Can you just write down 4 plus 16 and then times 4 for that one?
4 plus 16 times 4? It should be 4 plus 15 times 4. It's n minus 1 times 4. If you did 16 minus 16 times 4, you'd be finding the 17th term.
And that's because the first term you're doing.
Right, that's because the first term, I didn't add on any common difference.
So it's always going to be the less one. So
Yeah, minus 1. It's always going to be minus 1.
You have to put that minus 1, you can just put 4 plus.
If you know that it's always going to be 1 less, then sure. Yeah.
So if I put 15 instead of 16, that would have been correct.
If you put 15 instead of 16 minus 1, that would have been correct.
So you can just put 4 plus 15.
Now be careful with it, guys. Be careful with this. When I ask for the actual equation, I want this. You better know the n minus 1. Okay? When I just ask you for a specific term, then yeah, fine, do it however you want. Shoot, list them all out. It's only 16 terms. Go for it if you really want to. But I would not do that in this case. Right? You want to find the 60th term? Go ahead, list them all out. There's a blank there. 60th, that's the blank.
Are you gonna trick it out with that spot, dude?
No, you get. You're here. No, don't do that. Again, the formula is a sub n is equal to a sub 1 plus n minus 1 times d. What's a sub 1 in this case?
16. No,
I mean,
they're
the
11.
one-
So
11.
But
A sub 1 is always your first term.
but the a to the n is 60.
so
Hold on. What's d? Let's take it piece by piece. You're getting too far ahead of yourself. What's d? Gio?
Minus 6.
Minus 6. Negative 6 in this case. Remember, a negative d value will make the sequence go down. Does this d value decrease? So it's got to be a negative d. Now, I'm going to pause there. I'm not going to deal with the 60 just quite yet. Because I need to create the equation. A sub n is equal to 11 plus n minus 1 times negative 6. Now, I'm going to use parentheses because it's negative, and I don't want to confuse that with the subtraction sign. So I'm just going to write it like that. Shoot, you want to reduce this? Reduce it. To distribute in the negative 6, add the 11 in with it, go for it. Make the full equation. Because again, it's just linear. It's just a linear equation. But you can leave it like this. I like to leave it like that so I can see exactly what pieces are what. Now, that's part of my answer. And then the last part of my answer. Please don't say a sub n is 60. That's not true. N is 60, not a sub n. N is 60. Okay, that does not mean the same thing. A sub 60 is the term that you were looking for. N is the 60th term. Okay, so that means 11 plus 60 minus 1 times negative 6. So then we can take 11 plus 60 minus 1 times negative 6. And that would be negative 343. Okay, that's the 60th term in this sequence. 11 plus 60 minus 1 times negative 6. Questions about that? So let's go back to our very first problem of the day and see how good our guesses were. Let's go back. Let's find the 412th term of this sequence. So let me ask you, what is a sub 1? Negative 11. What's D? How much am I increasing by?
4.
And now what is N in this case?
Negative 11.
Oh, be careful. 412. Right? Now, did it ask me for any type of equation? No. All I wanted to do is just find the 412th term. So I could go right away and say, okay, so A sub 412 is negative 11 plus 412 minus 1 times 4. Let's see. Negative 11 plus 412 minus 1. I mean, if you want to make that 4 and an 11, by all means. 1633.
I got it. Yeah, I did too.
Yeah.
Mr. Laverick, you don't have to do the equation.
Your guess was 654.
No. Do the equation. That may work in your brain. That may not work in everybody else's brain. Deal?
Yeah, but
Don't confuse people.
no, I know. But
Your brain works different. That's okay.
Why would I have to memorize the equation that I didn't even do?
Because you're doing the equation anyway. What
Yeah,
you're doing is
I
That was
equation.
thousands away.
You see the same place?
Yeah.
Just that random number.
Yeah. Now, be careful.
It's
Be
like,
careful.
shoot, like
Quiet, please.
4,000.
There's a good conversation going on. Be quiet, please, because there are questions on this state test that say A sub n equals what? Give me the equation.
Okay.
You will have to know how to do it. You will have to know that given the equation. If you don't, you're going to miss points for that. Could you still find what the 412th term is? Of course. But what's my equation to get there?
Okay.
Okay.
Oh, by the way, you owe me a high five. Because I got it right.
Oh, did you get it right?
I got it right too.
Did you really?
Yeah.
Let me see.
That was a few
It's in the
thousand
back.
away.
High five.
I was like,
High five. Do your homework.
I got it right.
Anybody else?
I was like 60,000.
Yours says 1,029.
I was doing
Well, I can't read your handwriting anyway.
It's
about
obviously.
All right, here we go. Let's turn off the video. So long, everybody playing along at home.